Imagine this: humanity builds the most advanced spaceship in history. The engines are roaring, the scientists are crying, and the government has spent way too much money. Finally, the day comes. We are launching the mission.
Leave the solar system.
Okay, not go to Mars, not Saturn, not even Pluto. Actually leaves the sun behind and head into interstellar space. Sounds possible, right? I mean, we've already sent spacecraft beyond the planets. We've landed on the moon, we've explored almost every corner of our cosmic neighborhood. So why not just keep going? Well, because the problem isn't that we are bad at building rockets, the problem is that space is so absurdly huge that the solar system itself is basically a giant trap. And today I want to answer one question: can humans ever leave the solar system? And if the answer is yes, how hard would it actually be? Before we answer that, we need to clear up one thing first. What does leaving the solar system even mean? Because depending on where you draw the boundary, we've either already done it or we are not even close. So, first, let's figure out where the solar system actually ends. And that is where things start getting messy. When most people picture the solar system, they imagine the sun, the eight planets, maybe Pluto if they are still emotionally attached, and that's about it. But the solar system is much bigger than just planets. You've got the rocky inner planets, the gas giants, dwarf planets, asteroids, comets, the Kuiper belt. And then, far beyond all of that, you reach the really strange part: the Earth cloud, which is a huge shell of icy object surrounding the solar system. And it is not a nice little ring, but a giant cloud of frozen leftovers from the early solar system. And it stretches unbelievably far from the sun. So far that if Neptune feels distant to you, the Oort cloud basically looks at Neptune and says,
Oh, you think you are far?
now, here is the annoying part. There isn't one official wall out there with a sign saying, "Congratulations, you have now left the solar system." There are actually multiple ways to define the edge. First one is the planetary solar system. So, if you only care about the planets, then sure, once you pass Neptune and the Kuiper belt, you've gone beyond the main planetary region. The second way is the heliosphere. The sun constantly blasts out a stream of charged particles called the solar wind. This creates a giant bubble around the solar system called the heliosphere. When a spacecraft moves beyond that bubble, it enters interstellar space. And here is the cool part: Voyager 1 and Voyager 2 have already done that. So, technically, yes, human made objects have already entered interstellar space. But before we celebrate too hard, there is a catch. Voyagers isn't carrying humans. And if we use the Oort cloud as the true outer boundary of the solar system, then we are still nowhere near fully getting out. So, from a human point of view, the real question becomes: can humans travel far enough to leave not just the planets behind, but the solar system as a whole? And to understand why that's so hard, we need to talk about the real villain of this story: distance. We are absolutely terrible at understanding space distances. Our brains are built for things like the shop is 10 minutes away or my university is across the city, but not for this frozen rock is billions of kilometers away. Now let's start with something familiar. Earth to the Sun, which is about 150 million kilometers. That already sounds ridiculous. Now go outward. Neptune, the farthest major planet, is around 4.5 billion kilometers from the Sun. And even Neptune is nowhere near the true edge of the solar system. The Kuiper belt stretches beyond Neptune, and then much farther out, you reach the Oort cloud, which may extend tens of thousands of astronomical units from the Sun. An astronomical unit, or AU, is just the average distance between Earth and the Sun. So imagine the Earth Sun distance. Now multiply it by thousands, then by tens of thousands. That is the scale we are dealing with. To put it brutally, if the planets are your neighborhood, the Oort cloud is the other side of the country. So when people ask why don't we just leave the solar system, I kind of want to answer, sure, and while we are at it, why don't we just walk to the moon? Because the biggest problem isn't finding the way out, it's surviving the journey. Let's say tomorrow humanity decides, alright, we are leaving the solar system. How long would that actually take? Well, let's look at one of the fastest and most successful spacecraft we've ever built. Voyager 1, which launched in 1977, and after nearly 50 years of travel, it has only just reached interstellar space. That is an incredible achievement. It is also not very encouraging if you are planning to put actual humans on board, because humans are not postcards. You can't just throw them into space and wait 40,000 years for delivery. And that's the problem. Our current spacecraft are not built for human interstellar space. They are probes, tiny machines that has no food and oxygen. So if we want humans to leave the solar system, we would need a ship that is unbelievably fast, incredibly reliable, able to carry life support for years, maybe decades, shielded from radiations, and strong enough to survive far from any rescue. And right now, we do not have that. Not even close. Even reaching the outer solar system with humans would already be brutal. If you are talking about the Earth cloud or beyond, then the mission stops sounding like a normal space trip and starts sounding like a civilization scale engineering nightmare. But speed isn't the only problem. Even if we somehow solve the travel time, space would try to kill us in several other ways. Okay, let's pretend we somehow solved the rocket problem. Now we have a fast spaceship. Great, you still have to keep the humans alive, and that is a whole different disaster. Number one problem we're gonna face is time. A long mission means years of human problems. People age, people get sick, people lose motivation, people do not behave well forever inside tiny metal tubes. A trip lasting decades is already difficult. A trip lasting centuries? You are not planning a mission, you are planning a moving society. Let's look at second problem, which is nothing but radiation. Earth protects us with its atmosphere and magnetic field. Deep space does not care about your skin, your DNA, or your future. Outside Earth's protection, astronauts are exposed to dangerous radiation from the sun and from cosmic rays coming from outside the solar system. Over long periods, that becomes a serious health problem. So now your spaceship doesn't just need engines, it needs to be a flying shield. Problem number three is resources: food, water, oxygen, waste recycling, medicines, spare parts. Ah, everything has to come with you or be recycled almost perfectly. Because in deep space, there is no, oops, we forget something, let's go back. And if one critical system fails halfway through a multi decade mission, that's not a bad day. That's the end of the mission. Now, here is the last problem we can face: isolation. Humans are not built for extreme isolation. Astronauts on the International Space Station still have regular communication with Earth and know they can come back. Now imagine being so far away that Earth becomes just another bright dot in the dark. No rescue, no quick return, no fresh air, and no normal life. At that point, the challenge isn't just physics, it's biology, psychology, engineering, medicine, and honestly, patience levels that I personally do not have. So, if living the solar system is this hard, does that mean it's impossible? Not necessarily, but it does mean that if humans ever do it, we probably won't do it the way most people imagine. So, could we ever do it? Here is the honest answer. Yes, humans might leave the solar system one day, but not anytime soon. And definitely not with today's technology. If it happens, it will probably require one of these things: much faster propulsion. Something far beyond chemical rockets. Maybe nuclear propulsion, maybe fusion if humanity ever gets its life together, maybe giant light sails pushed by lasers, or maybe some technology we haven't invented yet. Because if your trip takes longer than a human lifetime, that changes everything. Generation ships. This is the wild option. Instead of sending one crew to arrive at the destination, you send a giant self sustaining ship where multiple generations live and die during the journey. So the people who arrive are not the people who left. Scientifically, it's fascinating but emotionally terrifying. Suspended animation or life extension. Science fiction loves this one. If humans could sleep for decades or live much longer, then interstellar travel becomes less impossible. Still extremely hard, but less ridiculous. Last but not the least option is robotic exploration first. And this is by far the most realistic near term path. Before humans ever leave the solar system, we'll almost certainly keep sending smarter and smarter robotic probes farther and farther out. Machines can survive journeys that humans can't. They don't need air, they don't get bored, and they don't ask if the mission can stop for snacks. So for now, robots are our gods. Humans are still stuck at the planning stage. So, can humans ever leave the solar system? Maybe, but the real answer is this. The solar system is not just a collection of planets. It's a gigantic cosmic territory ruled by one star, stretched across distances so absurd that even our best spacecraft looks slow. We haven't failed to leave because we are lazy or we don't know where to go, but because space is enormous, humans are fragile, and sun's backyard is way bigger than our brains naturally understand. Right now, humanity is still a tiny civilization living on one rock, orbiting one star inside one system. But the fact that we are even asking this question is kind of amazing because it means we are already thinking beyond home.